Okay, we're going to talk about SI prefixes. And you've seen these before. Maybe you haven't seen all of these before, but there's a bunch of them. You've probably seen and are familiar with maybe centi, deci, milli, deca, hecto, kilo. That's usually the ones you learn maybe in middle school. King Henry died drinking chocolate milk, whatever. There's a saying. There's a lot more prefixes, and the prefixes are really useful to discuss measurements that are either really big or really small. And it's good to get into the habit of just kind of automatically, when you get an answer that is an enormous number or a tiny number, it's good to get into the habit of just automatically throwing it into the nearest prefix that fits. This table lists the official SI prefixes that are used. It goes all the way from 10 to the 24, so enormous, all the way down to 10 to the negative 24, so super tiny. Yada, zeta, exa, peta, tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, femto, atto, zepto, yocto. Some of the ones that are stranger sounding, some of the ones that are more unfamiliar to you are probably really strange sounding, like zepto and yocto and atto sound really weird. Yada. These things sound like they're made up, I know. But they're useful. A much more reasonable range of prefixes is right here on this number line. So basically from 10 to the 12 to 10 to the negative 12. I would expect you to have these memorized. And once you use them a good bit, it's not that hard. It's not that hard to remember these once you start using them. There's a somewhat of a pattern with the big prefixes, so the things that are greater than 1. Mega, giga, tera, peta, exa, zeta, yada. Those are all capital letters because they're big. That's literally why they did that. I don't know why they didn't do it for kilo and hecto and deca. They could have. Maybe because capital K is Kelvin already. I don't know. But the small ones, the things that are less than 1 fractions, are all lowercase. So that helps a little bit. The table itself, if I see this measurement, 23 capital Y with an M, anytime you see a unit that is more than one symbol, it's possible that that unit has a prefix. It's also possible that that unit is actually just more than one symbol. Like this unit right here, this is called a Pascal. It is a unit of pressure. It's 2 letters. The first one is capital. But if you look at the SI prefix chart, there is a capital P. So that can get pretty confusing, and I'm aware of that. A is not a unit that I know of at the moment, so it's not a peta A, whatever that is. This is Pascal. So sometimes when you encounter a unit label, it's hard to tell, if you're still unfamiliar with all the prefixes, it's hard to tell whether or not this YM is itself a unit, or if Y is a prefix and M is a unit. You'll get the hang of it as we do more. But here, I mean for this Y to be a prefix, yada. 23 yada meters. That's a really long distance. And to figure out what that number is, if I want to switch go from prefix to scientific notation, it's easy. You just replace the prefix with the power of 10. So 23 times 10 to the 24 meters. So you see how this power of 10 just replaced the prefix? There's still 23 out front, there's still meters, but you just replace the prefix with the power of 10. Bang, done. If you want to go from scientific notation to a prefix, you just, so let's say I've got 1.3 times 10 to the negative 15 seconds. A very short amount of time. I would just replace the power of 10 with the relevant prefix. Equals 1.3, and that's right there, femto, lowercase f, s. 1.3 femtoseconds is 1.3 times 10 to the negative 15 seconds. So it's easy to switch back and forth if you're looking at a number. That's one way you can use these. And the other way is we can use them in dimensional analysis when you are doing conversions. So let's say you wanted to convert 42, I don't know, let's go with a crazy one. Zepto, so that's a Z. Zeptonewtons. A newton measures force. So this is a super tiny amount of force. And I want to convert it to some number of pounds. Well, you're going to need a little bit more information. One thing that you'll need is that 1 pound is 4.45 newtons, exactly. And then the other thing is this conversion factor does not get you to zeptonewtons. So you need to write down a conversion factor between newtons and zeptonewtons. And the easiest way to do that is, you see, the prefixes in the table over here, you will remember the power of 10 that goes with a prefix. Like micro is 10 to the negative 6. Giga is 10 to the 9. Those numbers usually you'll either remember or you can easily find on this table. So the way to use that is you say 1 zepto Newton equals, and then write whatever that power of 10 over there is, 10 to the negative 21 newtons. So the way that you can use the table, one of any of these is equal to that power of 10 of the normal base unit without a prefix. I'll write some more. You could say that 1 terameter equals 10 to the 12 meters. You could say that 1 nanometer equals 10 to the negative 9 meters. 1 kilometer equals 10 to the 3 meters. That one you might just remember. 1 exameter, and I just keep using meter. You know, these prefixes can go on any unit. They don't just go on meter. 1, let's say, exakelvin. So that's a lot of temperature. 1 exakelvin equals 10 to the 18 Kelvin. That is how you can write down a conversion factor from the table up here so that you can then use it. So if I could go back to this problem, I would do 42 zettanewtons times a conversion factor, 1 zettanewton, 10 to the negative 21 newtons on top, then 4.45 newtons on the bottom, and 1 pound on the top there. And then I could do the calculation. Um, 42 times, and then I'm going to show you how to do scientific notation on your graphing calculator, because it's not as straightforward as you might think. Okay, there we go. So 42, one option to enter this 10 to the negative 21 is you can just type 10 to the little caret symbol, negative 21. And that works fine if all you're doing is like 1 power of 10 and the calculation is not very complicated. And then I would divide by 4.45. And so the answer is 9.44 times 10 to the negative 21. 9.44 is 10 to the negative 21 pounds. But officially, the way you should enter, so that E right there means times 10 to the, and the number that comes after it is the exponent on the 10. If I wanted to enter a number, like if I wanted to type that number in to the calculator, the way you do that is 9.44. Then there's a little blue EE above the comma, so you do second comma, and that puts the E, which is a shortcut. The calculator thinks of that E as times 10 to the, and then you just type a regular number after it. You don't put an exponent. That breaks it. Now I can't get rid of the exponent. 9.44 second comma negative. You just put negative 21, just like a normal number. And the calculator knows that when you type that, it is scientific notation. You don't have to put, don't put a times and then a second comma. Don't put an exponent, but both of those things will break it. And when you have a big calculation and lots of different numbers that are all in scientific notation, I promise you the built-in scientific notation on the calculator will stop you from making mistakes. Resist the urge to type 9.44 with a times and then a 10 and then an exponent. So don't build it manually, because when you go, like if I divide now, and let's say I want to divide by another number in scientific notation, if I put times right here and 10 and raise it to a power to the 2, that is not what you think it is, because the calculator does not group this very intelligently. Like you probably meant to divide by this whole thing on the bottom down here, but that's not what you did. You divided by 2.5 and then got that, the calculator gets an answer and then it multiplies that answer by 10 to the 2, which is really not what you meant to do. You can avoid that problem if you just do 9.44 second comma negative 21 divided, clear, I hit clear, 9.44 second comma negative 21 divided by, and I don't remember what number I said a while ago, 2.5 second comma blah. That is how you should do calculations with scientific notation, because it treats that whole thing as one number and that whole thing as one number, and it does the division like you would expect. Okay, the last thing I'm going to show you is how to easily convert a number to using an SI prefix when it's not exactly on one of the SI prefixes. So if you were doing a calculation and the answer to your calculation was 1.7 times 10 to the negative 7 seconds. There is not a prefix, an SI prefix, that has times 10 to the negative 7 as its value. So you just go look for one that's close to it. If you look on the chart, 10 to the negative 7, that's pretty close to micro. So all you got to do to use the SI prefix micro is rewrite this number so that it has 10 to the negative 6 as the power of 10. Well, 10 to the negative 6 is a factor of 10 bigger than 10 to the negative 7. So the way that I remember how to do this is if this part of the number gets bigger, then this part of the number has to get smaller. Otherwise, you're going to change the value of the number. So, and you're always changing things by power factors of 10 whenever you play with the numbers on the exponent of the 10. If this number got bigger by 1, so there's one more power of 10 right here, so there needs to be one less power of 10 over here I don't know if that makes as much sense for you, but to me that it always seems like a balance to me. And if I well, no, that's a bad example. If I put an extra 10 there and then I remove a 10 there, it's not balanced. Whatever you do to this, you've got to compensate over here so that the total value of the number doesn't change. And now that I wrote it like this, seconds, I could do 0.17 microseconds. So this is to go to convert to a convenient prefix. What's another one? Let's do another one. Okay. If your computer can store 15 times 10 to the 10 bytes, you could rewrite that 10 to the 10 is not a prefix if you look at the table. The closest one is probably giga, 10 to the 9. So you could rewrite this as 10 to the 9. So that's one less factor of 10 right here. So I need one more factor of 10 over here so that this number is the same as it started. The actual value of the number is the same as what it started with. And then I can rewrite it as 150 gigabytes. You don't have to always go to the closest one if it's more convenient. So 10 to the 10 is not too far away from tera, which is 10 to the 12. So you could also convert it to 10 to the 12, and that's two more factors of 10 and right here, so I need two less factors of 10 out there. So this could be written as 0.15 terabytes or 150 gigabytes. These things are equal to each other. So it just depends on what you think is convenient when you convert to the nearest prefix. I'll show you a neat feature on calculators. If you go to mode, and then right here it says normal, that's what I've been on. Sci means that it forces all answers to be in scientific notation. So 10 plus 2, normally your calculator would just display 12, but I put scientific notation mode, so it forces it to display the answer in scientific notation. The other option, engineering option, is really convenient sometimes because what the engineering option does is it attempts to force the answer to be one of these. It attempts to force the answer to be one of these powers of 10 so that you can just really quickly read the answer off with a prefix out in front of it. So, like, that's not how it works. You could do like 1200 times 15. See, now scientific notation would never have displayed this for you. It would have, in scientific notation mode, you would have gotten 1.8 times 10 to the 4. But 10 to the 4 is not one of the prefixes. So instead it finds the nearest prefix and it gives you that. So this method is convenient when you want to report an answer using a prefix and you just want the calculator to figure out the closest one for you. All right, that's all, folks.